put on the graph now? It's the y-intercept. So is it -2 on the x line or the y line, Tushar? The y line. I go to -2 and I can put my dot. Now, do I know how far to rise and run from there? Yes. How far do I rise? 3. If I'm going to rise +3, what direction is that? Up. 1, 2, 3. And I'm actually going to draw that because it helps. Now, what is my run? 2. +2. What direction is +2 for our run? To the right. 1, 2. And then I put my dot. Now, just to be safe, I should have how many dots in a straight line? 3. I went up and right, so where else should I go? I could go up and right again, but I would be better to go down and left. So you can practice going both directions from your slope in case you run out of space on a graph. Then I connect the line. Is that correct? Is that correct? The line ends there. The domain is -2 to +2. How far does it go? Forever. So really this line should go like that, shouldn't it? Does everybody understand? Once again, you have the formula. You do the stuff to make this look like that. Everybody good? All right. Now, X and Y intercepts. What is every single X-intercept in the universe? No. X, 0. It is some value of X and 0 Y. What is every single Y-intercept in the universe? 0 on the X and some value of Y. Have I written number, number? Have I written something, something? Something, something. So this is X's and this is Y's, correct? What do I have in that equation right there? I have X's and Y's, so what can I do? Substitute in. X is still X. 6X plus 3. What's Y? 0 plus 12 equals 0. 6x plus 12 equals 0, because 3 times 0 is 0. What's my job if I ever have a single variable? Isolate it. What do I need to do to this to isolate that x? I need to take away 12 from both sides. Now, we're in the 10th grade now, ladies and gentlemen. I'm expecting you to be able to do this. Bring it over the equal sign and change the sign. You all know that trick. If you don't, you do now. Right? Because when I do 0 take away 12, I'm going to get -12, aren't I? So that 12 has just moved over. So now I have 6x equals -12. Now what? Divide by 6. And what does x equal? -2. X equals -2. What letter do I see right there? X. What number can go there now? -2. So I know I have -2, 0. Should I put that on the graph now? No, just in case y is a fraction. And I might need to change the scale. So let's check y. 0 for x. 6 times what? 0 plus 3 times y plus 12 equals 0. What happens to the 6 and the 0? Gone. 3y plus 12 equals 0. 3y equals -12. Y equals -4. What letter is that? Y. What does y equal? -4. So what can I write there instead of y now? -4. So I have 0, -4. Now, do I have an x and a y that I can put on the graph? Yep. 1, 2, 0. Do I have an X and a Y that I can put on the graph? Yes. 1, 2, 3, 4. And there's the line. Oh, sorry, it should have been -2. Idiot. -2. -4. And there's the line. Does everybody understand? Okay. In the last question, I have a slope. What letter represents slope? M. What's that? X. What's that? Y. What's that? X. Another X. So we can call him X2. What's that? Y2. Do I have an equation that uses M, X1, Y1, X2, and Y2? Yes, that equation is this. M equals Y2 minus Y1 over X2 minus X1. Do I have to memorize that? I do if I've lost my data booklet, like probably most of you. But if you haven't, you've got it. When will you have it? Will you have it on the test? Yeah. Will you have it on your final? Yeah. Because I am not in the business of testing your memory. If this was memory 10, we would all have cards with animals on them on our desk, and we'd all be turning them over. This isn't memory, this is math. What goes where? What goes in for M? -5 over 4. What goes in for Y2? Y. Minus. What goes in for Y1? 1 over. What goes in for X2? 5. Minus. Just wait. 5 minus -3. Now, a couple of days ago when we were doing notes, I foolishly thought that everyone would recognize immediately that minus became a plus, and I stupidly did my notes that way. That's my fault. The formula says minus whatever x1 is, so write it out properly. Now, when you go to tidy this up, what will you change that to? A plus. -5 over 4 equals y minus 1. What is 5 plus 3? 8. Something equals something. What do you do? Cross multiply. What is -5 times 8? -40 equals. What is 4 times y? 4y. What is 4 times -1? -4. What is your job whenever you see a single variable? Isolate it. This 4 is coming over here, yes? To become what? +4. What is 4 minus 40? -36 equals 4y. Now what? Divide by 4. What does y equal? -9. Y equals -9. What letter do you see right there? Y. What number can I now write there? -9. And that's the answer. Could you have done it graphing? Yes. You could have gone to -3, 1, 2, 3, 1, and done your slope. Down 1, 2, 3, 4, 5, over 1, 2, 3, 4. Still not at +5, am I? Down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. There I am at +5, and that is -9. Okay. X comma y, x's and y's. In which equation? All of them. How many equations are you going to learn this unit? 3. 4. You've learned 2. M equals y2 minus y1 over x2 minus x1. and y equals mx plus b. You're going to learn two more, and they all work the same way. If you have an x and a y, you can put them in. Everyone is good? Turn the page over. Parallel and perpendicular lines. First one's easy. Everybody put a dot at -3, 1. And then put a second dot at 1, 3. And I'm going to zoom in on that to make our lives easier. Does everybody agree I have created a section of a line? Now that line would go on forever in both directions, yes? But we're just going to work here. What is that line's slope? 3/4. 2/4, right? I went up 2 and I went over 4. So the m is really 1/2, right? Because 2/4 simplifies to 1/2. Is everyone good there? Yeah? Okay, now, if I slide this red dot 5 steps over, 1, 2, 3, 4, 5, and I slide this black dot 5 steps over, 1, 2, 3, 4, 5. What have I just made? I've made the exact same line, yes? What will its slope be? 2/4. What if I do that again? Is it still 2/4? So what, you just saw it happen 3 times. What does that tell us about lines that are parallel? What are the same? The slopes are the same. How often? Every time. So, oh, we're frozen solid as usual. Silly me. Parallel lines have the same slope. You can see that. The problem is most of you forget that the reverse is also true. If 2 lines have the same slope, then they are parallel. What is the definition of parallel lines in the physical world? They will never, ever touch. Do we understand that? Totally frozen. Spectacular. We'll just wait a moment. Now, while we are waiting, on the next graph, please put a dot at -7, 0. And another dot at -7, 8. -7, 0 and -7. Lines have the same slope, and 2 lines with the same slope are parallel. Okay, now the first dot I wanted was at negative 7, 0. And negative 7, 1, 2, 3, 4, 5, 6, 7, 8. And that makes that line, yes? Now, put a dot at negative 9, 4. And a dot at negative 3, 4. What have I just made? The lines cross, yes? What is special about where they cross? It makes a 90-degree angle. These are what we call perpendicular lines. Everybody understand? Everybody good? Okay. So, what is the slope of the vertical line? It's undefined, which means what's on the bottom? This is line 1. Remember, the slope of line 1 has to be rise over run. Well, if it's undefined, what's the run? What's not allowed to be on the bottom? 0. Everyone agree? And does it matter what's on the top? No, because as soon as you have 0 on the bottom, it's undefined, right? So this is simply a number. Yes? Now, would that number be a y value or an x value going up and down? It's a y value going up and down, yes? Okay. Here is line 2. What is the slope of line 2? It's still rise over run. It's 0. So where is the 0 now? On the top, and on the bottom is just some number, yes? What do you notice about the 0 in both cases? What happened? It reciprocated, didn't it? So if that happens once in math, how often will it happen? Always. So, 1, perpendicular lines, and we all know that the word perpendicular means they meet at 90 degrees. Everybody sees that, right? You can see it right in front of you, yes? The 0 was in the denominator, now it's in the numerator. That is the definition of reciprocal. Is everyone good? Yeah? Okay, now slide over to the other side of this graph, because something else happens here, okay? Put a dot at 2, 1. And put another dot at 5, 7. Oops, not line 4. That's our third line. That is line 3. Everybody cool? Okay. Now, put a dot at 1, 2, 3, 4, 5. 5, 1. Sorry, that's 6, 1. 6, 1. 1, 2, 3, 4, 5. And 0, 5, and make a line there. Everybody got it? Everybody got it? Okay. Now, that is line 4. What is line 3's slope? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It is 6 over 4, correct? Which simplifies to what? 3 over 2. Agreed? What is line 4's slope? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4 over negative 6, which simplifies to what? Negative 2 over 3. What do you notice about the numbers? They're reciprocated, right? And what do you notice about the slopes? The black line has what kind of slope? Positive. The blue line has what kind of slope? Negative. What do you think is this angle right here? What did you just learn about perpendicular slopes? Perpendicular lines have slopes that reciprocate. Did these slopes reciprocate? Okay. Now, but they also went from positive to negative. That makes sense, doesn't it? Because if they're going to cross, one must be positive, the other one must be negative, yes? So that's the other thing about perpendicular slopes. I forgot the R. Perpendicular lines have opposite slopes. They both have to be true. So parallel lines have the same slope and will never intersect. Perpendicular slopes have what kind of slopes? Opposite reciprocal, right? Opposite reciprocal slopes. And how many times will they intersect? What? Once. They will intersect once at a 90-degree angle. Everybody cool? So, the only thing we've learned is if I have a perpendicular slope, it's opposite reciprocal. Otherwise, is it still x and y's? Is it still y2 over y1, x2 over x1? Right? Okay, let's see if we really get this. If my line is 2/3, what's its perpendicular slope? -3/2. Opposite reciprocal. If my slope is -7, what's my perpendicular slope? 1 over 7, because that's really over 1. If my slope is 4, what's a parallel slope? 4. Could it also be 8 rise over a 2 run? Could it be a 64 rise over a 16 run? Yes. Everybody understands that, right? Okay. -5/11. What's the perpendicular slope? 11/5. Slope is 0. What's perpendicular? Undefined. Slope is undefined. What's the perpendicular slope? 0. Is everybody good? That's the only concept. Other than that, nothing else changes. So let's see. Turn the page over. Is ST parallel, perpendicular, or neither to AB? What is the thing that tells us if something is parallel or perpendicular? Slope. So I have to check the slope of AB and the slope of ST, correct? The slope of AB is always y2 minus y1 over x2 minus x1. And the slope of ST is then what? The same thing. Where do I get those x's and y's to do this work? Right in the question. The yellow ones go with which? Red or black? Red. Why? Because it says ST. The green ones go with what? Black. Because it says AB. Green, yellow. Fill it in. The only decision you're making is which is x1, y1, which is x2, y2. So, are they parallel? Are they perpendicular? Or are they neither? They are perpendicular. Why? Because the first one has a slope of negative 1/2. The second one has a slope of positive 2. Positive 2 is really 2 over 1, isn't it? Are those opposite slopes? Negative, positive. Yes. Are they reciprocal slopes? 1 over 2, 2 over 1. Yes. So these are perpendicular. Now, for everybody that did not say perpendicular, I cannot read your mind. You need to look right now and see where you made your error. Now, I will help you out by saying I made this one y2 and this one y1, which made that x2 and that x1. If you reverse them, you will still end up with the same answers. Is everybody good? Okay. Let's go to the next question. Is this a right triangle? If it's a right triangle, what does that mean? What does it mean? One of the angles will be what? 90, which means two of those lines are going to be perpendicular, aren't they? But there's 3 corners, isn't there? So we would have to check 6 slopes. Who wants to check 6 slopes? I don't. So how do we make it easier on ourselves? We sketch a graph. Where is point A, which will be red? -3. 1, 2, 3. And up 1. Everyone agree that that's point A? Okay. Where is point B, which will be blue? 6, and down 1, 2. Does everyone agree that that's point B? And point C will be green. Where is that? 1, 2, 3, and up. 1, 2, 3, 4. And then we make our triangle. Where is the only possible right angle right now? The red, the green, or the blue dot? The green dot, yes? So I have to check this slope, and I have to check this slope, don't I? Between red and green, which is my red dot? A, so there's an X1, Y1. Where's my green dot? C, so there's an X2, Y2. How do I check the slope there? I do the equation. The slope equals y2 minus y1 over x2 minus x1. If I write it down, is it possible to do it wrong? I don't think so. y2, 4, minus y1, 1. x2, 3, minus x1, -3. Tidy it up. 4 minus 1 is 3. 3 minus -3 is what? 6. Do I ever leave fractions like that? No. What is it? 1/2. So that is the red slope. Does everyone agree? Okay. Now I need to check this light green slope, which is between the green dot and the blue dot. Well, I've already got my green dots with x2 and y2, so what should I make these guys? x1 and y1. And then I do the same thing. y2, 4, minus y1, -2, over x2, 3, minus x1, 6. What is 4 minus -2? 6. What is 3 minus 6? -3. Would I ever leave that fraction? What is it? -2. In slope, I need a rise and a run. So what is this really? Over 1. That's the green slope. What do you notice? Are they opposite? Are they reciprocals? So what does that make this angle right here? 90, which makes that what kind of triangle? A right angle triangle. Now, if we were going further in math, once we have a right angle triangle, can we now do trig with it? Yeah. Can we now do Pythagoras with it? Yes. That's why knowing this perpendicular thing will help us do further math later on. Is everybody good? Okay. I think that's it. Oh no, I lied. Turn over to page 201. Soon as I see that, what do I have? I have x and y. Soon as I see that, what do I have? X and y. Soon as I see that, what do I have? X and y. Soon as I see that, what do I have? X and y. If I want line AB to be parallel to line CD, then what does that mean for their slopes? The M of AB must equal the M of CD, correct? Right? Because if they're parallel, they'll be equal, yes? Right? Okay, so how do I find the slope of AB? X2, Y2. Easy peasy. I'm just going to write it out, okay? 10 minus 5 over 7 minus 3. What is 10 minus 5? 5. 7 minus 3? 4. Equals. What's the slope of CD? You do the same thing, ladies and gentlemen. A minus 2 over 1 minus 0. Now, can I solve that? Sure I can, because it's 5 over 4 equals A minus 2 over 1. Do I have fraction equals fraction? So what do? Cross multiply. What's 5 times 1? 5. What's 4 times A? 4A minus, what's 4 times 2? 8. What's my job now? Separate it out to isolate the variable, right? So where's this 8 going? Away from the variable. And what does he become? Positive 8. Plus 5 is 13 equals 4A. Now what? Divide by 4. And A equals 13 over 4. How many different ways can I write that? Is it also 3 1/4? Is it also 3.25? Do I care how you write it? No. What's the quickest way to write it? Right there. Because that's how the algebra gets us, right? And you can leave it like that. It's done. Everybody cool? All right, now look at the next question. I want line AB to be perpendicular to line CD. Well, that means that the slope must flip over, yes? And change signs. Well, don't I already know AB's slope? What is it? AB is 5 over 4, but I don't want parallel. What do I want? So what do I do to that? I flip it to what? Negative 4 over 5. Does CD change? No. What was CD? It was A minus 2 over what? 1. Now what? Cross multiply. What's negative 4 times 1? Negative 4 equals, what's 5 times A? 5A minus, what's 5 times 2? 10. What do I do with that negative 10? Comes over here and becomes what? Positive 10. What's 10 minus 4? 6 equals 5A. Now what? A equals 6 over 5. How many ways can I write that? 1 1/5 or 1.2. Is everybody cool? What's the only thing we learned today? Parallel and perpendicular slopes. Parallel slopes aren't even hard, are they? What happens with a parallel slope? Everything stays the same. So we really only learned one thing. 2 words. Perpendicular slopes, opposite, reciprocal. Does anything else change? Are we still using Y2 and Y2 and Y1, X2 and X1? So we're good, right? I would suggest you be ready for a quiz. Because see how it's the next thing on the list? A refreshing sip of my coffee. It's still too hot to take a long sip because I'm a bit of a wuss. About hot things. Are any of you like that? I can eat spicy things, but hot things, I'm a candy ass. Soup, I'm sitting there. My wife, where's the rest of it? I've had her send soup back in a restaurant that is still boiling. You know when you get the French onion soup in the restaurant that comes out with the cheese on top and it's still bubbling? You guys ever get that? And because it's come out of the oven, it's just about as hot as lava? Do you really, Prab? I think you're a bit of a liar. How often do you order French onion soup? Really? You know what I'm talking about, Malik. With your last name, you probably eat a lot of onion soup. You're a liar. Yeah? It's one of my favorites too. But I think it's mostly my favorite because of that giant pile of cheese on the top. Like, really. You could put a giant pile of cheese on just about anything and you'd probably like it. The bread is nice too. Yes. Do you like the chunks of bread or do you like one big chunk of bread on top that you cut into pieces? What do you prefer? You like the little pieces in there? I like the one big piece because it holds the cheese up there. Yeah, I like floating one big piece. Yeah, and then you cut it up with your spoon. That's how I do it. Why wouldn't we talk about it, Rylan? Nobody does math in here. We might as well talk about French onion soup. Want to know how I know nobody does math in here? I got a homework check. That's a gutsy call. My personal favorite soup is bacon, potato, and cheddar. Chili is, I would argue chili is a stew, but really. If you like soup and you find yourself in Boston Bar, British Columbia, on the drive to Lytton and Williams Lake and stuff, there's a restaurant by the bowling alley that has all-you-can-eat soup all the time. And they have at least 4 soups at any given day. So you can go there and eat soup until your back teeth are floating. French onion soup really is a meal. I don't know why they say it's an appetizer. Because you eat it and you're like, and then they bring out your plate. You're like, can I get that to go? I know what you're saying. Yeah. Huh? Oh, miso soup. See, miso soup isn't filling. That's nice. Like just let's have some sushi. Right? But let's do math. Oh, soup talk. Soup is way more interesting than math.